Unit 6, all about arrays, one-dimensional arrays. We call those 1D. So I'm going to go ahead and create the Unit 6 in my computer science project here. I'm going to create a Unit 6 package, all lowercase, no space. I'm going to create a class in my Unit 6, call it Array Project. I'm going to put a main method in this, create. All right, so I have my array project here, and this is where we're going to be working throughout Unit 6. Now, the first thing I want to do is I want to make some arrays, but I want to also make the arrays of different types just so we could see. I also want to make an array of bank accounts, okay? And if you remember, bank accounts was in Unit 5, right over here, okay? Unit 5 right here. So bank account is not in Unit 6, but I want it in Unit 6, so why don't I import it? I want to import unit 5.bank account, okay? Because I want to use it in here. Well, since I imported it, it's now possible to make a bank account. I'm just going to illustrate this before we start looking at the arrays. So we make a bank account, and of course, if you remember, there was a toString, so system.out print, and I'm going to print A, because remember the default constructor had a bunch of nulls and zeros and so on. So let's run that. That's what we got. Account numbers 1, 2, 3, 4, 5. You remember that, the balance and all nulls. Okay, so it's possible to get something from another unit by importing it. Okay, now I don't want to necessarily do this. That was just for illustration, but later we will build an array of bank accounts. So let's talk about arrays. And so first I'm going to bring up a picture here, and I'm going to show you what an array looks like, one-dimensional array. ARR is the name of the array, and each location, each cell in this array has an index. The first guy is indexed at 0. Computers always start at 0. Second one is at 1, and then 2, and then 3, and then 4, and then 5. So these are 6 things, off by 1 here, 6 things. The last guy is at position 5. Now I don't know what data is inside here, and it really doesn't matter because arrays are very flexible. You can make an array of anything. So anything can be in here. Any object or primitive or even an array could be in here. Now to access this information, you access it by putting the name of the array and these nice square brackets with the index inside. So if the 0 is in here, I'm accessing the guy at position 0, whatever that data is. This is the variable, okay? So whatever the variable, so there's 6 variables here, all right, all indexed. The first guy at 0, the next guy at 1. So if there's a 1 here, I'm looking at the variable here. So whatever is in there. And again, that could be anything. So what we want to do now is I want to actually make one like this, and I'm going to put in some values inside of it as well. Okay, so I'm going to start off with integers. So let me go ahead and start off with integers. Let's make an array. Int A1 square bracket equals to a new int square bracket. I'm going to put 5 things in. So let's see how this syntax works here. That's the name of the array. That's the type of information I want to put inside the array. The square brackets are absolutely essential because that's the only way I know it's an array. And this number over here is how many I have. This is called creating an array. This is initializing an array. Creating an integer array. And this integer array hold 5 things. So the first guy is at position 0 and the last one is at position 4. Alright, I could put this after the name or after the type. This is a flexibility. If you put it here, you're thinking like this. I have an array of integers. If you put it where it was before, you're thinking A1 is an array. Okay, it just all depends on how you think about it, but either way is fine. Of course, you see main, who happens to be static, and he has an array as well. See where the square bracket is? On the type. It's an array of strings. I could put this take this off and put it over here. No problem. So right now I just created an array that holds 5 things, but there is nothing inside of it yet. Well, there's no such thing as nothing. In a computer, there's a default value. It's filled with zeros. So if I want to populate it, I can say A1 at position 0, put a 1. A1 at position 1, put a 2. And then A1 at position 2, put a 3. And then A1 at position 3, put a 4. And then A1 at position 4, put a 5. All right, so I just created it, and then I populate. So populating, let me put this a little bit more obvious here. Populating this, we could have done it with a loop. Yep, we could have done it with a loop, writing a loop to do that, but this is literally showing you how the position 0 now holds a 1 and 1 and so on. That's one way to do it. Okay, you make it with the spaces and then you put the stuff in after. The other way to do it, there are 3 ways. The other way to do it is this array here. I can say new int and then put the stuff in immediately. So I could go 1, 2, 3, 4, 5. This is creating it and populating it all at once, as opposed to a 2-step process here, where I've created the space that hold all zeros, 5 of them. Then I put the stuff overriding the 0. Okay, overriding it with these numbers. Memory is destructive. This guy is doing this all at once. There's another way to do it. Now you just have to choose the way that makes sense to you. Yeah, you don't need this. Okay? You could decide not to and just do it immediately. This is a shorthand version of this. So we can do this, then put them in. We can do this, put them in at the same time, or we could do it this way. Now, that's how you make an array, and that's how you put the stuff in. What if you want to know what's in there? I'm going to print. Let's say print A1 at position 0. If I run this, I should be printing a 1. Nice. Now I can print A2 at position 0. I should print a 1 as well. So easily you can access the stuff that's inside there by giving the name, the square bracket with the proper index. If I say, hey, print position 2, A2, so let's see, that's 0, 1, 2. That should get me a 3. Remember, it's off by 1. Now, that's just a matter of making these things and printing them, which is very crucial. The other thing I want to show is that the type doesn't have to be ints, okay? All my examples here are ints, but it could be anything, right? I could make an array of doubles. Let me call this A4. Remember the type, and I put 5 things in there. And then I could say A4 at position 0, put a 0.0, or let's put a 1.0, just to be consistent with the one before, and A1, A4 at position 1, I'm going to put 2.0. So you get the idea. I could go ahead and fill this up with more values, 2, 3, and then 4. And I could do 2, 3, 4, 5. Okay, so I could make ints, I could make doubles. How about if I make a string? String is 6, another array, equal to, this time I'm doing the days of the week. Monday, Tuesday, Wednesday, Thursday, why am I can't spell Thursday, and Friday, got two Ds. Friday, Saturday, and then finally, make this a little smaller, Sunday. So let's call this, instead of A6, let's make a good name, days, right? So I've created a string array, and it holds all the days. You know, another thing with these things, I'm calling them A1 and so on, but sometimes when you're writing these things, you should really call them something nicer, like values or days or something like that. So here we have it. We can make array of doubles. See how I did this one? I did this array of doubles like I did the first one. But yet I did the last one the third way, which is the array of strings. That brings us to the end of 6.1.